can. We've still got some people coming in. Yeah, hi, Len. Come on, everybody, squeeze in. Let the people have seats. If there's an empty seat next to you, like, don't just take half of it. It's kind of rude. Let somebody have it. We're good. All right. Is everybody ready for this? Good. That was the one person. Screw you all.
Thank you. Glad you're here.
Yeah! That's better. Who's going to the party tonight? Yes. Yeah. The one with free beer? Yes. Nice. Last minute sponsor bug trap. Thank you. Free beer, always good, right? Do we like free beer? Yeah. Okay. There's also drink tokens. The sponsors have the drink tokens. Don't mug them. Anything up to physical is allowed. Okay? Not included. So that physical world part of his talk, not the vendors, okay? Not the sponsors. Please do not mug the sponsors. Except him, he has drink tokens. Get him!
Ah!
We have parties today and tomorrow. If you're not at both of them, I hope it's because you're at a better party or unconscious in the corner somewhere. Not in the hotel, please, thank you. Not the elevator. Or halfway out of the elevator. Or halfway out of the elevator, or urinating in the elevator. Or out of the elevator, except in the bathroom. Ladies and gentlemen, SCOTUS.
Good morning. Oh, thank you. Very kind. I am so excited to be here at DerbyCon. I tell you, I was supposed to be at the first DerbyCon, right? It was, what, 3 years ago? I got an invite. Relic sent me an email. I was ready to present. I was so excited about it, and I wasn't there. My wife actually had surgery, and they had some cancer stuff, and they had to go in and take it out. I hate to start with this, but it's building to something good, okay? She had to have chemo and radiation, so I missed the first DerbyCon. I'm delighted to report that my wife is doing awesome now. She's fantastic, so that's very cool. And I've spent a good amount of time in hospitals. Have you looked at the security, the IT infrastructure in hospitals? Holy mackerel! Oh my gosh. That kind of fueled some of the ideas I'm going to talk about here. Then last year, I got an email from Relic, right? He sent me an email saying, "Hey Ed, can you come to DerbyCon too? I'd like to have you present there." I couldn't come. Why? Well, I was actually at BrewCon and was having a good time. It was a wonderful con, right? Soon as I finished with my BrewCon talk last year, it was tweeted, you know, Ed's talk is done. I got an email from Dave Kennedy saying, "Next year, your ass is mine." And what a nice thing to say to somebody. So here I am this year, and I'm really excited to be talking about what me and my guys have been working on for the last 2 years. The talk is called Kinetic Pwnage, Obliterating the Line Between Computers and the Physical World. You see here just a nice little tranquil town, right? Yeah, we'll talk about that town in a little more detail in a minute. For those of you that I haven't met, my name is Ed SCOTUS. Here's a little bit about me. I like the command line, as you can tell. Introducing myself via the command line. A little kung fu here. I'm using the cut command to pull out the fifth field from a colon-delimited file known as etc password. What's the fifth field? Come on, say it. It's a hacker conference. Fifth field. It's the GCOS field. Yes. Pulling out the GCOS field, piping it through grep in a case-insensitive fashion to pull out my last name. And you see on the screen the largest GCOS field you've probably ever seen. Also one that includes bullets in it. Anyway, I started working at Belcor quite a while ago. Here's my Twitter stuff. I'm a SANS instructor and author of the 504 and 560 class. I founded a company called CounterHack, and we build simulations. You can call them capture the flag events if you'd like. Simulation sounds a little bit fancier. We do things for high school students like cyber foundations. In fact, we have 7,000 high school kids registered for our next competition there. We do stuff for college students called CyberQuest. We do stuff for professionals called NetWars. And we built some stuff for the military and government critical infrastructure providers called CyberCity. I've got a blog that I do. I work on the Command Line Kung Fu blog with Hal Pomerantz and Tim Medine. I also do some blogging over at the SANS Pentest blog. All right, so here's what we'd like to talk about for the next hour or so. A little bit of historical grounding, see what has gone before. And then I have my central thesis. I'm going to put it out there, see what you think about it. We'll talk about why the central thesis is so and some of the implications for it. We'll talk about the CyberCity project as a way to manifest some of those things. And then I'll have a very short manifesto, and then I'll ask you to get involved. A call to action. What can you do? What do we as a hacker community need to do to head off what could be some pretty big problems? And then we'll finish with conclusions. if you go back to the origins of the hacker community, I mean, where did this kind of stuff start? This idea that we should be manipulating technology to understand it, make it do things, find flaws, make it better. There's a lot of different origins. I had always thought, given my work at Belcor, I had always thought that this was something that grew out of the phone phreaking movement, right? It was the 70s phone phreaking, Captain Crunch, all those folks. That's the beginning of hacking, surely. Well, actually, if you go back about 30 years before that, there was a very active hacking community that started to use the term hacking to mean what I just said. Manipulating technology to make it do stuff people didn't expect it to do, to make it better, more secure, etc. In fact, at MIT, the Tech Model Railroad Club, the TMRC, built very elaborate computer-controlled railroad systems, miniature railroad systems. They had all kinds of fantastic stuff. It's detailed in Stephen Levy's book, Hackers, Heroes of the Revolution. Anybody read that book? It's a good book, worth reading, talking about the origins of our community. They built all kinds of things. Look at these industrial control systems they set up here. They also built this building, and the building, the lights go on and off in the building, and they built a Tetris game on the side of the building. Now, that's a cool hack, right? Right? Awesome. All right, so it goes back to that. And if you think about it, the beginning of this hacking movement and the idea of hacking from 1946 involved using industrial control systems to control physical assets moving around. There was this tie in between the physical world and the computer world in a beautiful way. All right, my central thesis is based on that. I think we are now in the golden age of hacking hardware and software together. You guys know Joe Grand, right? He's going to be presenting later today on JTAG stuff. Looks like an awesome talk. I saw him present back in 2009. It was at the Hack in the Box conference. And Joe got up and he made this declaration: hardware is the new software. Black is the new blue, or blue is the new, whatever. Anyway, hardware is the new software. Also, you've certainly heard Dual Core song, right? Hack all the things, drink all the booze. When I first heard that song, my first reaction was, all the things? Seems mighty ambitious. Maybe we should just hack half of the things. Or about 70. Look, I'm okay with drinking all the booze, but all of the things? And I started to think about it. Yes, my friends, we need to hack all of the things, because the hacker community has to find these vulnerabilities and drain the swamp, or very bad things will happen. Think about, it's going to sound like buzzwords here, but think about the ideas underlying these buzzwords and how they're kind of all swirling together, centered around the hacker community. Embedded systems, Internet of Things, wireless, mobile. There's an app for that. Jailbreaking, the hobbyist culture. We're talking the maker movement, the hacker movement, all coming together on this thing. And the thing is manipulating hardware and software to have kinetic impact. This is awesome. You remember the cute little sign here where people have hacked into one of these little street signs and says, "Caution, zombies ahead." And that's fun and silly and cute. Larry Pesci in the house, when we say fun, silly, and cute and refer to zombies, you think Larry, right? Anyway, this is cool. But wait a second. Really bad things could happen here. With the manipulation of the kinetic infrastructure via networks and computer attacks, we'd have really big problems. You guys just heard HD talk about the idea of accessing natural gas and other related infrastructures and causing a little probe in there to heat up. Scary stuff, and that's scratching the surface here. And then think about it. Is the InfoSec community ready to deal with the coming attacks against kinetic infrastructures? I don't think so. Over the last 20, 30 years, many of us have worked really hard to try to stop breaches, to try to protect information, and to try to protect access of our computer systems. And frankly, we have failed. And if we don't get better at protecting the kinetic infrastructure, it's going to be a rough ride the next decade or so. All right, so some recent talks at hacker conferences and stuff coming up. At Hack in the Box Amsterdam, 2013, it was April of this year, there was a talk on remotely hacking airplanes. Did you see it? Did you see the description of it? There was some controversy about whether the equipment that the gentleman had bought on eBay to do the analysis was realistic. The FAA issued a little press release saying that the configuration he used is not actually flight ready. They were very, in fact, shockingly specific about their denial, saying that specific configuration is not one that is used in the wild right now, therefore his findings are questionable. But yeah, what about other configurations of the same kind of equipment? In fact, RenderMan's doing a talk later today on manipulating air traffic control systems. So we got planes, okay, what else have we got? There was a talk last year at DEF CON, exactly, on hacking trains in Spain. It's got a nice little rhyme to it. Hacking trains in Spain, the gentleman talked about in his presentation, I saw it at DEF CON, how he was able to go into a train station in Spain and get access to the little things that describe which trains are coming on which tracks. He was able to display arbitrary messages on there. So he could have had people going to the wrong trains and the wrong tracks. Or he could have caused a panic, right? Maybe having people trample each other. He says he was able to get access to some systems which appear to actually control the train switching, but he didn't want to mess with that because that could really hurt people. All right, so we got trains. And then, did anybody here see Charlie Miller and Chris Valsek's talk at DEF CON this year? That was awesome! Oh my gosh, I'm telling you, it's one of the best talks I've seen in the last 2 or 3 years. You need to see it. I was just looking to see if it's on streaming video this morning. I did not see it yet, but when it comes out, and it will, you've got to watch this talk. It was brilliantly conceived, it was beautifully executed, and there was some serious, fascinating hacking going on there. You see, these two gentlemen procured a couple of automobiles and hacked the car area network, injecting messages into the car area network to cause things to happen, like to take control of the steering, take control of the brakes, take control of the lighting system, etc., etc., etc. It was fantastic. Did you notice that a lot of people, in commenting on Charlie's amazing work here, said, yeah, but you have to have access to the car area network. You got to be like in the car or connected to it. There was some additional research from the University of California the year before on how to get wireless access to the CAN, right? So they're saying, well, Charlie's work was just focused on this one piece. No, Charlie opened the whole CAN up, no pun intended, so that if you can get remote wireless access to it, which you can do in a variety of different ways, shown by the University of California research, you can manipulate cars and cause all kinds of mayhem. Craziness. Yes? I don't know. The gentleman's question is, the theory that Mercedes that was hacked into and caused somebody to get killed was a government-sponsored thing. I don't know. I don't know. But let's focus now more on some of the areas that are concerning underlying my basic thesis. IP everywhere. When I was a child, we used to build little communication systems. Me and the guy who lived a few blocks down when we were in 2nd grade, we strung wires between our houses so we could send Morse code back and forth between each other. Today, kids wouldn't even think of doing that because you can just text your friend, right? But we've gone so much further than that. Now we've got IP everywhere. So from a residential perspective, you've got baby cams with streaming video of your child over IP. Thermostats, refrigerators, home automation, IP, IP, IP. If you go into, say, the retail space, cash registers, grocery stores, shopping malls, most commerce happening over IP. If you go to the critical infrastructure, you got electricity, you've got water, you've got sewage infrastructures, industrial and military equipment, all IP. And this provides great connectivity, and lots of things are directly connected to the internet. You heard HD refer to some of the stuff connected directly to the internet. Shodan is a wonderful place to find things directly connected to the internet, so you can look and find cameras. There was a paper that was presented at Black Hat about a month ago, where somebody had done a bunch of scans and found a bunch of systems connected directly to the internet with streaming video, including some that were in Chinese military bases. Fascinating. So you look in and see what's happening at the Chinese military base. All right. And it's worse than that, though. It's not just what Shodan shows us. It's also stuff that is on an internal network. If that internal network is connected to the internet, that stuff on the internal network is indirectly, but still connected to the internet. Even if it's on a separate IP network, eventually it will be connected to the internet because IP loves IP. They're best friends forever, you see? IP connects to IP. And you say, but Ed, air gaps. Air gaps. Just get your wire cutters ready, we'll cut all the stuff. I don't believe in air gaps. At best, an air gap is a high latency connection. But make no mistake about it, it is a connection. Why? Because air gaps disappear over time. You might have a brilliantly crafted concept of a security architecture, and you put in the appropriate air gaps in the appropriate place. But the guy who takes your job after you is not going to be as smart as you. It's just, you can agree with me on that, right? Yeah. So he's not going to understand why that air gap is there, and he's just going to connect the stuff together. Or your accountants, they're not going to understand why you have the air gap there, and they're going to say, we can manage that thing from 1,000 miles away using somebody that's much cheaper than the local folks if we just get rid of your air gap. So IP loves IP. It craves interconnectivity. And this isn't just a wireless thing, although wireless is a profound issue here. But even on the wireline, air gaps get connected. On the wireless, I mean, think about where we've come so far and where we're headed. Your computer systems probably have Wi-Fi connection. They have Bluetooth connections. We're working on getting some near-field communication in a lot of the computing devices. I bet you in 5 or 10 years, there's going to be 8 or 10 or 15 different forms of wireless communication with your system, and you're not going to know whether they're all off or not. So air gaps really don't exist. If your security model depends solely on your system being air gapped, you're probably going to get owned. Maybe in the future, maybe now. Another issue that we've web-apped everything. We've put web-based control systems in front of all these back-end Kinetic infrastructures. So security equipment, right? You've got your enterprise vulnerability scanning solution. You've got your VPNs. You've got your enterprise security suites. Most of them are configured via a web app. You've got HVAC systems. HD referred to that, right? Heating, ventilation, air conditioning systems. They've got web app front ends on them now. Power grid controls, smart meters, all web-based interfaces. In fact, when I was working with InGuardians, we were doing some analysis of some of the smart meters, and we found a cross-site scripting flaw in one of the smart meter systems. So it was actually the meter that sits outside of your house, had a web server on it, and it had a cross-site scripting flaw. So you could, a long-term, persistent cross-site scripting flaw. So you could plant a script on that and wait for somebody in the electrical company to run a browser and read the status of your meter. And now you've hooked their browser, right? Get a beef hook in there and start manipulating things. We reported this to the smart meter vendor. We talked to the product manager, and the product manager said to us, you guys don't know what you're talking about. There's no web server on our meter. There is a web server. It's listening on TCP port 80, and it's on your meter. No, there isn't. Well, look into it. So he looked into it, called us back a day later and said, you know what? There is a web server on our meter. Well, yeah, that's what we're trying to tell you. He said that one of their customers had asked for a certain feature that their development team implemented via web server on the meter. They put it into the firmware, and it got pushed into the whole product line. Oops, the product manager didn't realize this. Okay. Automotive systems with web-based interfaces. I took my car in for service. Drove my car right into the mechanic's service center. He takes this probe out, plugs it into my car, rolls over this little cart, runs a browser to read the status of what's happening on my car. I'm thinking I could probably trick out my car with certain statuses that was SQL injection attempts or maybe cross-site scripting, injecting that back into his browser. Do you think the mechanic closes the browser after I drive my car away and the next car comes in? So imagine a cross-site scripting attack via your local auto mechanic. Right, my car's got a browser script in it. I drive in there. He does service. I drive away. The script stays in his browser. Your car comes in after, and my script starts attacking your car. Lovely. It's all web-enabled. Cross-site scripting, SQL injection, cross-site request forgery, remote file include. All this stuff we're finding all over the place. Command injection. Huge number of command injection flaws in these things. That paper that came out that was focused on different kinds of web cameras, IP-enabled web cameras, had a whole bunch of different command injection flaws. And this is to say nothing about owning the underlying operating system. So we've webified all this stuff. Maybe we'd have some big problems with it. Now you say, but maybe you're still on that air gap thing. You're still on that air gap thing. You see, most of your energy companies, electric utilities, have an OT network and an IT network. Operations, technology, this is the thing that controls the SCADA systems and so forth. And then you have your IT network, where you have your employees sitting there with their computers, with their web browsers. And these are separate networks, heavily fortified and separated from each other. And sometimes you'll see public utility commissions interrogating, effectively it's interrogating, the people that run these networks. They're asking the executives, as well as some of the technical people in the company, tell us more about how you're protecting these things. And here's the question that the PUC sometimes asks, public utility commissions, these are the regulators. Is your OT environment connected to the internet? And their answer, usually, is no, it isn't directly connected to the internet at all. Now, what's the important word there? Directly, exactly. Because as we know, right, the hacker community, outbound access and the ability to get responses is equal to inbound command and control. Reverse shell, anyone? Right? Right? And there's plentiful opportunities for jumping between the IT and OT network. Let me give you a couple of examples. You have your industrial control system. Maybe it's for an electric utility. Maybe it's for a water company, something like that. It's pulling data, sampling the flow of electricity or the flow of water every second or every 5 seconds. It's storing it into a data historian. The data historians use to track to see how things have gone over time. The data historian is putting that into a common database on the OT network, which replicates to a database on the IT network so folks can do analysis there. So you can see how we can jump between these things. You then go for this replica on the IT network to a workstation on the IT network, and now you get access directly to the internet. Lovely. So a command and control channel of the OT network. Let me tell you another one. I was talking with a friend of mine. He is a power grid security engineer, one of the best guys I've met. He's asked me not to mention his name here. But he was going on a tour of one of the electric utilities, and they were showing him how they set everything up and how they had secured it. So he's walking through, and this power grid engineer guy is showing him various things. Over here, we've got the OT network. Here's how we control this. Here's how we configure that. Over here, we've got one of the workstations with the HMI, the human-machine interface, that we use to control the various PLCs. Oh, if you wouldn't mind, hold on just one second, he said, during this tour. And he took his phone out, plugged it in, and connected it to the PC that was running the HMI. And my friend, the security guy, freaked out. What the heck are you doing? Dude, I'm just charging my iPhone. It's okay. Yeah, just charging your iPhone. Well, wait a second. There's LTE on that phone, and now it's got a direct connection via USB to the PC with the HMI interface. So from smartphone to HMI PC to Pwnage, all right? Or the OT systems. Many of the OT systems can resolve names. DNS, right? So OT systems resolving names using DNS to get to the IT environment, which then do a full recursive lookup, and you get internet access in Pwnage there. DNS Cat, created by Ron Bose a couple years ago. Fantastic example of what you can do with very heavily firewalled off systems that can still resolve names, giving you command and control or data exfiltration. Also, I'm not even touching on this idea of USB plugging in with just, say, a thumb drive, like Stuxnet supposedly used. Now, sometimes when I talk about kinetic attack via the computer infrastructure, I hear this stuff. In fact, I was doing a presentation at the SCADA Summit earlier this year. It was in January. There were 276 people that do SCADA security in the room. So much smaller than this audience, actually, which is kind of cool. All right, anyway, 276 people in the room, and I was going through how different attacks could function, and somebody raised their hand and says, wait a second, Ed, wait. There are physical controls which override the computer controls. Things like pressure valves, so that if you've got this particular system, the pressure valve will release the pressure, so it's not going to actually explode. Or there's dampening systems that prevent the centrifuges from going too fast, and so forth. Also, somebody else raised their hand and said, but Ed, we have humans in the loop. Humans are there to make sure really bad things don't happen. So what you're saying doesn't matter. My response to that? Well, first of all, with these dampening effects, or especially pressure valves, hacking the system to cause the pressure valve to release pressure could in itself cause massive physical damage, right? Releasing some sort of poison gas into the atmosphere or something like that. Scary stuff. Don't think your pressure valve is going to save you. Also, increasingly, these override systems that were supposed to be physical are actually being turned into computer control systems themselves, right? What's to say the centrifuge can't spin that fast? Oh, in the old days, there would be a little dampening system that would open up, so it just didn't have enough energy to spin at the speed you wanted because of the centrifugal force. Nowadays, increasingly, oh, there's something in the firmware that says don't spin that fast. Oh, we can take care of that. Yeah. For low-cost operation, oh, and here's another big thing. For low-cost operation of remote equipment, this is really big in oil and gas now. To have some people sitting out in the middle of well, the wilderness or maybe a desert, pumping gas, pumping oil out of the ground, to have human operators, it's very expensive. They don't want to go there. These are in hospitable terrain. So instead, they just allow for remote access to it. So 1,000 miles away, you have people that are remotely configuring and accessing these kinds of systems. Also, the final one, and this one's really important. If anybody says to you, no, we've got humans, and they'll see bad things happening, and they'll fix it, think social engineering via the HMI, the human-machine interface. People react to what the computers tell them is happening in the physical world. And if the HMI says there's a problem, the human will try to solve the problem. But what if there is no problem? What if the HMI is lying to the human, trying to cause the human to make a problem? We have modeled this in one of the projects we're working on. It's called Cyber City. I'll talk about it in just a little bit. But in Cyber City, one of the missions that people engage in is they try to gain control of the HMI of the water system. You see, terrorists have compromised the HMI, and they've displayed things on the screen telling the people who run the water system that the water's contaminated. They're trying to manipulate those people into fixing the water by dumping chemicals into it. But by dumping chemicals into good water, they're actually going to contaminate the water in an effort to try to decontaminate. Are you with me on this? Yeah. Decontaminate the water. So that's just a classic example of manipulating HMIs to make people do the wrong thing, which causes the kinetic effect that the people themselves are actually trying to stop. See also Stuxnet, right? With Stuxnet, when it infected the system, it would display on the HMI, everything is fine, and then the centrifuge would die. So what do? You buy more centrifuges. Yeah, same kind of thing here. So 3 areas of major concern for me. Power grid, right? It's the mother of all critical infrastructures. Healthcare environments, huge issues there. I'm talking both hospital systems and medical devices. Major vulnerabilities. We've done a lot of research in hospital systems over the last year and found massive flaws in them, such as pre-authentication SQL injection. Pre-authentication SQL injection. Yeah, it's crazy stuff. Cross-site scripting pervades this stuff. And then weapon systems themselves. Weapon systems, configurable and controllable across IP networks. A bad guy could get in and disable or neutralize them so that troops can't defend themselves because their weapon systems just don't work. Or worse yet, turning the weapon systems on their owners or their own home country, causing massive problems. Now, there's other areas here like telecom, chemical production, aviation, and so forth, but these are the 3 that me and my folks have spent the most time focusing on in the last 2 years. How so? We built a little project, maybe some of you have heard about it, called Cyber City. I'd like to tell you about it briefly and then talk about some of the lessons learned and then move you into how you can get involved with this stuff, okay? So, I was in a military base about 3 years ago, and I was talking with the leadership of the base. And the leadership said, we need a way to teach cyber warriors that cyber action has kinetic effect. That's what we need to show them. But we want to do it in a safe fashion. We can't have people getting killed here or anything like that. So figure out a way to do it. And I wish I could tell you, oh, it was obvious. I just said, well, we'll build this little thing and it'll be great. No, it took 4 months of just brainstorming until we came up with this idea of building a miniature city 6 feet by 8 feet. It astounds me how much you can get in 6 feet by 8 feet, quite honestly. It seems kind of small, but you can do a lot of stuff. A miniature city with a real power grid, real water control systems, no real water, because I don't want the thing to flood, all right? But real water control systems, a train system with SCADA-controlled switching. We've got an ISP in there with routers and so forth. We've got a hospital running real hospital IT infrastructure and medical equipment. We've got a bank with free Wi-Fi. The terrorists use the free Wi-Fi. We've got a coffee shop and so forth. The free Wi-Fi is in the coffee shop, and they use it to hack into the bank. Participants so far have been .mil, but we're expanding it to .gov and .com and .edu. And of course, to see the kinetic effect, we have streaming video. So there's 5 streaming video cameras. Here you can see 2 of them overlooking the Cyber City project. There's another one in the sky, and then another one on each of the 4 quadrants. All right, some props to some thought leaders. My team built this. Josh Wright, you guys probably know Josh, Yori Kovichko, Tim Medine, Tom Hessman, and so forth. But we had some great input and ideas, brainstorming with folks like Skip Runyon from the U.S. Air Force, Mike Asante, who used to work at NERC, Terry McCorkle and Billy Rios from Cylance, Rita Wells is a great thought leader here as well, and so is Eric Bassel from SANS. Here's what Cyber City looks like as an overview. You see we have 4 quadrants. We have our industrial quadrant, where we have a water reservoir, that's the upper left. We got our power station, generates electric power, and we have a factory. The factory is a chemical factory with centrifuges. Upper right, this is our commercial quadrant. Here we have a hospital, we have a bank, we have our ISP, we have a social networking site we call FaceSpace. It's kind of like Facebook and MySpace kind of smushed together. But it is a parody, of course. It is not in any way abusing any of the trademarks of either of those organizations. All right. Next, we have our coffee shop. The coffee shop is a hotbed of terrorist activity. The terrorists go into the coffee shop, use the free Wi-Fi to hack into doctors' and bankers' laptops, and ride across the VPN into the hospital and bank. Lower right here, here's where we have the residential infrastructure. We have things here like a city hall, firehouse, some houses, and a school. The purpose of the school being there is to tell the cyber warriors, don't touch. This is not for you. We set up various missions that they have to achieve some kinetic effect in Cyber City, and they have to follow the rules of engagement. They're all written as formal military operation orders. So they have to go through their operation orders, and the operation orders say, don't touch the school. Now, it might be that it's very easy to achieve your mission objective if you simply hack through the school, jeopardizing the school. You're not allowed to, see? And then on the lower right, we have our military. Whoa! Lower left, we have our military infrastructure. Here we have a rocket launcher, so we've got a weapon system, and a landing strip, as well as some barracks. This is a deep network as well. We have built in here an entire IT infrastructure. So, for example, the bank has a public-facing website, DNS server, mail server, as you might expect. It's got an intranet site with all kinds of things on the internal site. The hospital has a public-facing DMZ and an intranet site, and so forth. We've got HMIs in the OT network of the power grid, and so forth. So let me give you a briefing on some of the missions that we have. The first mission we have is with the power grid. So Cyber City has a real power grid controlled by real systems. We've got Siemens General Electric and Allen Bradley SCADA systems in there. And I'm going to tell you a little bit later about how you can get some of your own so you can start experimenting with this stuff. Yes? Yes, that's it. So these actually control little miniature things. It's a tiny city, 6 feet by 8 feet, with actual buildings. I'll show you some Cyber City porn in just a minute. Now, by Cyber City porn, I mean pictures designed to titillate and excite, not naked people. Okay, you'll get to see this. So there's a tiny little city that is actually controlled with a real power grid. And I'll show you the power grid in just a minute. So here's one of the missions. One of the missions is terrorists have hacked into the power grid. Oh, that sucks, right? They've caused a blackout. Oh, that's a bummer. And your job as a cyber warrior is to hack back into the power grid to turn the lights on. Oh, but guess what the terrorists did? They reconfigured all the computer systems so that the energy company, the utility itself, can't turn its own lights back on. So you actually have to hack in, retake control of the power grid, and turn the lights on. Now, when we originally came up with this idea, we thought it was a bit contrived. I mean, really? Really? That the utility company itself couldn't turn on its own lights because the terrorists had manipulated it? So it was last November, about 10 months ago, I was presenting in front of about 30 power grid engineers. And I said, I'm going to tell you about our mission that we're working on for the power grid. Just want to run it by you. And I said, it's going to sound a little contrived, but let me walk you through it. So I walked him through it. At the end of me walking through the mission, a guy raised his hand, one of the best power grid security engineers in the room. He said, Ed, that's not contrived at all. That's our worst case scenario. You nailed it right there. It's like, dude, wow. Okay. Transportation. Here's one for the transportation. So that's mission possible, right? Transportation. Bad guys hack into our control systems for the traffic lights. Josh Wright created this. It's a very realistic traffic control system. What do the bad guys do? They hack in there, they turn all the traffic lights green at the same time. What do you think that's going to do? Death and mayhem on the streets. Your job as a cyber warrior is to fix that, make the traffic lights work, or at least set them all red, which is still going to cause its own problems, but still it's better than all green. Water reservoir. I told you about this one already. That is where the bad guys are trying to manipulate the HMI to make the people dump chemicals in the water that shouldn't go in the water. We had a huge problem when we were first doing this because our customers said to us, we want to see the water change color. And we were thinking wet water. And we're like, what are you going to do? Like inject little chemicals into the water so you can see it via the streaming video camera, turn a different color? How are you going to get the chemicals out? We want to be able to reboot this thing. Yeah, LEDs, exactly. It's obvious, but believe it or not, it took us like 2 months to say, you know, we can just shine some little lights. And the lights came out looking pretty cool. Train system. The bad guys have put a radiological bomb on the train. And they're going to take the train and drive it into the residential quadrant, detonating the radiological bomb, causing poisoning of that whole infrastructure. Your job as a cyber warrior is to take control of the SCADA systems that control train switching and derail the train so that it can never reach its target destination. And then the weapons system. Oh, the weapons system. Bad guys have compromised a military weapons system. They have aimed it at the residential quadrant, and they're threatening to shoot the hospital. Your job is to retake control of that weapons system, aim it harmlessly off into the horizon, and fire it. The reason you want to fire it is so that those weapon systems, the missiles themselves, will not be reusable because they fired off harmlessly into the horizon. That's what you've got to do. And I'm going to tell you what happened when we first ran that mission in just a little bit. Stuff happened. All right, so here's some Cyber City porn. Here's our Cyber City commercial quadrant. You can see here we've got our traffic lights. Over here is our coffee shop. Here's our bank. All right, so we got that going in there. You can see off on the horizon, that's where we have our industrial quadrant. Here's our military quadrant with our weapon system. Yes, it is a Nerf rocket launcher. But we built a user interface for the Nerf rocket launcher that mimics some real weapon systems and a control protocol for using that. Josh Wright created that as well. You can also see we've got our tower and we've got a landing strip. The mission on the landing strip is the bad guys are doing a denial of service attack, causing the lights on the landing strip to go out. You have to fight through the denial of service, or around the denial of service, or neutralize the denial of service so you can turn those lights back on and aircraft can land safely. Here's our industrial quadrant. You'll see here we've got our power grid with our utility substation here. We've got the train going by. Here's our chemical factory. Chemical factory has centrifuges in it. The bad guys are trying to hack into the centrifuges, causing them to spin too fast and tilt over, causing a fire inside of the chemical factory. Now, we don't want things to actually burn in Cyber City because it's really hard to reboot burn. So instead, what we've got is little laptop fans. We took a note from Pirates of the Caribbean, right? The Disney ride. We got a little laptop fan, and then we have some orange and red and yellow streamers on it. And you can see through the windows. We turn them on, and fire is happening inside the building. Yeah. Here's our residential quadrant. We've got the school on the left over there. You can see some of the houses and some of the The office building's in the far distance. So here's our power grid. Each quadrant of CyberCity is controlled by a separate individual PLC, each from a separate vendor. So you've got Allen Bradley, GE, and Siemens. It also controls the street lights as well. You can turn on or off any building individually, or the street lights on a quadrant-by-quadrant basis. We're using Wonderware as our human-machine interface, which is the most common HMI used, software used on planet Earth today for controlling things like electrical systems. It runs on Win 7 and Win XP. You might say, Win XP, that's old stuff. Why are you doing that old stuff? That's what they're using. Totally what they're using. In fact, as much time as I spend in hospitals, it was last week in my first hospital that was not on Windows XP in the last 2 years. It was on Vista. Oh. Nice try, guys. Nice try. Okay. Protocols, Modbus TCP, DNP3, Profinet, and Ethernet IP. We manifest them all in CyberCity so that you can hack them. Now, you might be saying what this gentleman might have been thinking a little bit earlier. Why is there an actual physical infrastructure at all? Why don't you just make everything a simulation? Make it SimCity on steroids? Not a bad idea, but there's two problems with that. First, the cost of doing it well, to make an entire synthetic thing that had the quality that people might expect from modern video games, would cost untold millions of dollars. The other thing is, it's just a true statement that some people in the military, if you presented them something that was an entire simulation, would say, thanks, but that's just a video game. That's not real. But by having an actual physical infrastructure that they can see via streaming video, they can say, oh, that's real. I just derailed a train. Yeah, the train was 6 inches long, but I derailed it. Yeah. It makes it more real by having something realistic. Yeah. It's also way cooler. Well, perhaps. It's been a tremendous, when we originally had the idea, it's like, well, we'll build a city, and we'll have a power grid, and we'll have some water systems, and we'll have weapon systems, and we'll have this, and we'll have a traffic system. That can't be that hard. Oh my gosh. It is like the hardest project I've ever been involved with, and I'm very thankful for the team to, just put so much time and effort into it. So what are the lessons we're learning here? So I got the lessons we're learning and then how you can get involved with this. First, everything we've deployed in CyberCity has been way less secure than we expected. Vulnerabilities everywhere. Cross-site scripting, SQL injection, buffer overflows, clear text protocols, hard-coded user IDs and passwords. In fact, we've actually had to recode some of the stuff just to make it secure enough to make for an interesting capture the flag simulation. Because if you could just own things trivially, we're not really demonstrating much in the way of advanced skills. It's ridiculous. The hospital systems, we used OpenEMR inside of CyberCity. And we found so many different flaws in OpenEMR that we couldn't deploy it as is. It was too brittle, it would keep crashing, and it was just loaded with cross-site scripting and SQL injection flaws. So Tim Medine from my team actually had to recode some OpenEMR stuff to make it usable as a capture the flag challenge inside of CyberCity. Yeah. These components just haven't gotten the scrutiny that they need to make them more secure for the trust we put in them to protect ourselves and our families. So what do we need to do? We as a hacker community need to help drain the swamp of vulnerabilities. That's what we need to do. There's also huge issues with responsible disclosure. The OpenEMR people were not pleased with our discovery of vulnerabilities in their stuff. They reacted as vendors often do. The first reaction was, what you have isn't real. It's just not that, and we showed them it's real. Second reaction was, what you have is not important, right? Cross-site scripting, it doesn't matter. And we showed them that it very much matters. Planting a beef hook and so forth is a pretty big deal. And then the response is, well, why are you picking on us? We're doing this free open source anyway. Why should we be held to any sort of security scrutiny? Seriously, I have all these emails with them, and I was so depressed. Finally, one of their lead developers sent an email saying, guys, what they have is real, what they have is important, and frankly, we need to fix it, and it's not that hard to fix. So let's just fix it. Whew. I should send that guy, like, I don't know, a chocolate or roses or something, I'm telling you. All right. So maybe you're thinking this. All right, Ed. Assuming that there's these problems you talk about, why haven't we seen massive kinetic attacks yet? Well, there's many possible reasons for this. First, there's no real serious way to make money on doing this in a way that people see right now. Right? There's no criminal model to get cash. You say, what about like some sort of extortion? We're going to make a blackout happen in this town unless you pay us. Yeah, but there's a world of hurt from law enforcement or even potentially military intervention if that were to occur. The geopolitics. Right now, maybe it's not in anybody's interest for critical infrastructure to go down, because if it were to go down, then we'd make it more secure, and then any vulnerabilities that will be needed for future engagement may be gone. So in other words, there's a certain interest in keeping the infrastructure relatively loose and insecure, because now the assets, long-term command and control, are being deployed. In fact, they are. At the SCADA summit that happened in January this year, there was discussions of malicious firmware inside of some industrial control systems in the power grid that was planted there. Also, it may be harder than is anticipated. I'm not seeing that from what we're doing in Cyber City, but perhaps it is. Skills for this type of attack aren't yet widely deployed. They're emerging, and maybe because they're not so widespread, we haven't seen much of it. I believe mostly it's the top two. The lack of an effective criminal business model, and right now it's a land grab for command and control. So don't harden the infrastructure because everybody wants to own it again and again. So the battlefield is being prepared. So the bottom line here is what I talked about earlier. The fact is we've done a pretty lousy job as an InfoSec community in protecting data and computers. And now that the computers themselves are increasingly being networked on the internet and used to control kinetic assets, we've got a problem. I mean, we've had breaches. Denial of service still is a recurring problem. And if we don't do a better job, I think the internet will grow even more militarized. Some of you are reading some recent stories about certain government agencies and thinking, how could it be more militarized? Oh, just wait. People may get hurt. People may get killed. So we need to vigorously apply the lessons learned. We're the hacker community. This is just awesome. What a beautiful time to be in the hacker community because we can actually help people. Help people by finding these flaws and then responsibly working with vendors who will hate you, will come after you, maybe even sue you to do the right thing. Okay, so props to the EFF. Thank you, guys. They are here to help us do this right. So, design, testing. Testing's where we come in. So a call to action for us. Start hacking all the things, like Dual Core says, right? You could drink all the booze too. But hack all the things. Do it responsibly, finding and properly disclosing these flaws. Pick an area. I really hope some of you will do it. Some of you have already been doing this for years. That's awesome. More of us need to get involved with this stuff. Maybe your area is going to be power grid. Maybe your area is going to be medical devices. Jay Radcliffe, a good friend of mine, he was looking at some insulin pumps a couple of years ago and found major flaws in them. He gave a presentation. It was very controversial, but he helped move forward the security of wireless insulin pumps. All right? Water control systems, aviation, and more. So how do you get involved? First, learn the foundational control protocols associated with each. If you choose the power grid, learn Modbus TCP, learn DNP3, learn Profinet. The beauty is a lot of this physical stuff is actually quite well documented. You can find a lot of information about the protocols. Windows, remember, we've been hacking Windows for decades, right? Or a lot of the PDF viewers, a lot of the Adobe software. That crap isn't documented at all, right? So you got to kind of figure it out, reverse engineer. Here, we've got some very detailed documentation of what's happening at the protocol level. There's some really ample documentation of what's happening in the chips. Read the docs and look for holes, options, and bad assumptions. In other words, read these docs and do them like a hacker. Make some friends and learn. Read a mailing list. Get yourself up to speed. Learn more about the certain industrial control system you're particularly focused on. Maybe it's water systems for you or power systems for you. Lurk on a mailing list for a while. Subscribe. Who's who? Who's important? Learn the lingo that they use to refer to the different things. Because sometimes they'll use language that's not exactly in the specs, right? Focus on protocols, vendors, and devices. And reach out to like-minded people at a con. You're here at DerbyCon, an amazing community-oriented conference. So attend talks on your chosen topic. Buy a speaker a drink. All right? And maybe there's no talks on your given chosen thing. I have a birds of a feather session. You know, post something on the bulletin board. Hey, you want to talk about, hacking, heart pumps? Let's get together and talk about that. Look, you might have some people who are very interested in finding out why you care so much about that. But have a birds of a feather session. Don't be intimidated. I talk to people about this all the time. They say, look, dude, I'm not an EE. I don't have an electrical engineering degree. You don't need an electrical engineering degree. You need the mindset of a hacker. A lot of the people with electrical engineering degrees don't have that mindset, and therefore they implement the specs, but they don't push on the edges of the spec. You got a field that can go from 1 to 255. Well, what happens if I put in 1 or 255 or 0 or 256? What happens? We think like that, and we need to find this stuff. All right. And then get hacking. Buy some equipment. It's going to cost you a little bit of money. First, get the manual. See if you can get the manuals for free. The last thing I want you to do is go out and spend $500 on a PLC. They ship it to you, and you find out it's not what you need and what you want. Try to get the manuals first and for free. They're often downloadable. All right, so get a free download, or maybe you could purchase the manuals for $10 or $100. Get the manuals, read those. Then look on eBay or PLC Center. Have you guys used PLC Center? I'm like a junkie now, PLC Center. Rocks. They sell all kinds of programmable logic controllers used for all kinds of industrial control equipment and so forth. So some examples of some stuff that we have in CyberCity. We have a Siemens PLC starter kit. It's an S7-1200 PLC. I've learned a lot from this little device. It's fascinating. I'll show you some more on it in the next slide. Also, we have an Allen Bradley L32E compact logic processor. And what you can do is build your skills to be able to sniff, just looking at the protocols going back and forth. There might already be a Wireshark dissector for it. If there isn't, make one. Make one. Yeah, that's cool. It's a great learning experience to build a Wireshark dissector for some protocol that, well, Wireshark doesn't have one for. Then work on injecting. Scapy is your buddy. There's a lot of good Scapy stuff out there. Also, it's fairly easy to add a protocol to Scapy, extending it. In fact, just recently, some people added Profinet injection capabilities to Scapy. Profinet is an industrial control system protocol that is widely used throughout Europe and the Middle East. We do have it in CyberCity as well. And then fuzz. So much of this stuff is so vulnerable that simple fuzzing can cause it to crash or find an exploitable condition. You can extend the Sully fuzzer in very nice ways, the Peach fuzzer, or even extend Scapy to do this. Cool stuff. About that Siemens starter kit that I mentioned, right? It's Siemens industrial control system, used widely throughout the world. I've got an overview at this URL. Some specs are here, and you can buy it for $430 at the PLC Center. When you go there, here's the spec sheet that comes up. And I brought up the spec sheet because there's some interesting things here. Profinet. Oh, that's widely used in Europe as well as in the Middle East. Fascinating. No module required. The vendors build these things in very modular fashion. And if you buy something and it requires an extra module, you got to buy the extra module. So look for no module required, or if there is a module required, look at how much that costs. And then you see web server. What should that, as a hacker, get you thinking about? Command injection, SQL injection, cross-site scripting, all of that stuff. Look for it. I'm sure you will find it. Okay? And then I mentioned that new Profinet Scapy-based fuzzer. That's cool stuff. All right. So in conclusion, we've kind of come full circle. If you think about it, MIT's Tech Model Railroad Club, this is the first thing I started talking about, they were using model trains to figure out hacking and what hacking should be and the ethos of information wants to be free and manipulating technology to make it do things it wasn't planned to do. They did that in 1946 up to today. And now we're actually using model train components. By the way, CyberCity is at HO scale. We did it at HO scale because you could fit a lot of stuff inside of 6 feet by 8 feet at HO scale, and you can buy buildings more affordably rather than having them custom built if you're buying just HO scale stuff. So we're using train components to model cyber attacks. We as an industry really have to up our game. There's a lot of work to do here. There really is, but now's the time. This is exciting. Maybe we're made hackers for a time just such as this. And I'd like to close out with this picture here. A month ago, we ran 53 cyber warriors from the U.S. Air Force through CyberCity, and it was exciting and fun, and they broke up into different teams, and they were hacking and so forth. And there were 2 teams that were working on the missile launcher mission. 2 teams working on it, and they're trying to hack. You have to pivot through a whole bunch of stuff to get to the missile launcher. The first team got to the controls of the missile launcher, and they were able to re-aim it. And they re-aimed it so that it would fire harmlessly off into the horizon. So they got their re-aim done. Good. Second team is continuing to hack. The first team can't figure out how to shoot it. They're trying, because you've got to reverse engineer the protocol to control this thing. They couldn't figure out how to shoot it. They're working. Second team gets control and figures out how to aim it. So they reset the aim so that it's pointed right at their own military base. The first team figures out how to shoot it and shoots it. Bam! It hits their tower right by their thing. And everybody in the room, 53 people, start applauding. Yay! Yay! I didn't want to be the bearer of bad news. But you hit your own tower. And this is an actual image of the tower after they had destroyed their own tower. You aim, then you check your aim, then you shoot. You don't just aim and then shoot, right? Yeah. Measure twice, cut once. Yeah. And I said, we've all learned a very important lesson today. There's a lot of issues with cascading impacts when it comes to some of this cyber action from a military perspective. You have to be really careful. And we're kind of seeing that stuff as we go through missions in CyberCity. All right, so that's going to bring us to a close for this and maybe open it up for questions and answers. Yes, sir. HO scale, so it's a scale for model trains. They come in a variety of scales. Z scale is really tiny. G scale is relatively large. HO is right in the middle. Yep. Yes. Are there any plans to implement social engineering add-ons to CyberCity? Right now, some of the initial entry vectors in CyberCity require sending email with, say, links in it or attachments. Now, Tim Medine has designed the scripts that are going to decide whether they're going to click on the links. And man, he's a bastard, I got to say. So you got to have like 99% of his criteria met in your email. And I said, Tim, let's loosen this up a little bit. Maybe just meeting 80% of the criteria. So it's scanning, actually, looking for certain keywords. It's not a real person. They're not just sitting there. And kind of a follow-on question that this gentleman's certainly thinking about is right now CyberCity focused on gaining control of these assets, but is it like team on team? Not yet. But we're working in that direction. We actually have requests for additional CyberCities so that then you can get team-on-team action so that you have to defend your infrastructure and attack the other guy's infrastructure while he's doing vice versa. We don't have that yet. We're working on it. 2014. Yes, sir.
What are some tips that you can give, this is a little left field, but for making vulnerable applications that are resilient and don't fall over?
Ooh. The gentleman's question is, what are some tips you can get for making resilient applications that are vulnerable, but yet they're resilient so they don't constantly fall over? First of all, just test the crap out of them. Because you might build something you think is resilient because you can go in and do it again and again and again, but the minute you add 2 or 3 or 25 people to it, it blows up. So first is just test, 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 test. Second, be very careful with back-end database interactions. Back-end database interactions can often be used to lock out other users. I've seen that a lot in the CTFs that I design. You got to be very careful with smooth background interaction with databases. The other thing is whenever you launch a browser, because oftentimes you want to do something. Somebody sends you an email, you want to launch a browser to process that. Make sure you've got good concurrency in that. Some of the browsers don't work well with concurrency. Excellent question. Yes, sir. Yes. The gentleman's question is, are we going to add more technologies to CyberCity? Yeah, the idea is, as long as the funding keeps coming in, we'll never be done with CyberCity. He specifically cites Zigbee. Yeah, we're working on some Zigbee stuff. The HVAC system inside of the ISP will use Zigbee. It doesn't yet, so that you can hack into it, manipulate some things via Zigbee, and raise the temperature in the data center to cause the ISP to die, right, because their routers just got too hot. That's the mission that we're working on. We don't have it done yet. But yeah, there's going to be Zigbee in there. A question from over here. Yes, sir, please. The gentleman's question is, any of the teams managed to hack into the back-end systems, such as the underlying virtualization servers or some of the laptops that control things? So far, not yet. It is inevitable, right, that this will happen, but we monitor the crap out of that. We have this whole idea within CyberCity. There's an internet in CyberCity. And then, of course, there's our underlying infrastructure. And we've got all kinds of rules to say, you know, you're allowed to move data out and in and so forth. There's a whole big thing that we have for all of our CyberCity developers of rules. And there's rules like, you know, how you maintain separation between in-game assets and out-of-game assets, how you assign passwords in-game versus out-of-game. That's important. You don't want to have any commonality between those two. And one of the other things is making sure all of your mission elements are rebootable, which we have mostly achieved. The problem is the rocket launcher has 4 shots, and then we have to reload, and the train can't automatically re-rail itself. Those are the only 2 current elements that can't automatically reboot. And the final vital requirement in CyberCity, do not burn down the town. So we do have sprinkler systems that we had installed for CyberCity just in case. I was talking to the power grid engineer. Tom Van Norman's his name. He did our power grid. The guy is awesome. Anyway, Tom Van Norman, I told him, I said, look, is there a chance somebody could hack into this power grid equipment and cause it to catch on fire? And Tom said, there shouldn't be, but I can't guarantee it. If somebody hacks in and writes a script to turn this thing on and off 100,000 times, it may catch on fire because that's not supposed to happen. So that's when we said, oh yeah, we got to get a sprinkler system. A question back here, yes. Yes. So the gentleman's question is, when you're building these scenarios with elements in CyberCity and you discover vulnerabilities, do you ever implement something to harden it against that? Yes, we do responsible disclosure with the vendors, but we also, just to make it realistic and being able to expose it before a fix comes up, we'll implement our own fixes. Many of those own fixes in the web apps aren't that hard to do. If they are hard in a given web app, we might even implement a fix. It's not a great fix, but it's something in a web application firewall up front. So we have used WAFs just so that we can get something that is relatively stable and not trivial to hack inside the environment. Over this way, yes, sir. Excellent. So the gentleman's question is, what makes for a good post-mortem so you can make sure that the lessons learned in missions like this, or even other CTFs, are actually being learned? I find one of the best things to do for that is to have the teams brief you. So you're the creator of it. So how did you approach this? this is cool from a lot of perspectives. One is you can see if they're learning what you wanted them to learn. The other thing is they're smart people, right? I mean, cyber warriors, at least in our case for the U.S. Air Force, they will often find things that we didn't expect. Holy crap, you hacked it that way? That's really clever. Oh my gosh. Of course, the next time we go through a debriefing, we'll say, did you notice this other way to do it? Yeah. So having them debrief you is a tremendous conversation. It's just not like they're debriefing you and you're checking to see whether they're any good, but instead it's a conversation. They're briefing you on how they did it. You're encouraging certain lessons to be learned, asking other questions, and frankly, you're learning while you're doing it. It's a beautiful interaction. Other questions? Yes? Yep. We have not. The gentleman's question is, have we done anything with air traffic control inside of Cyber City? Not yet. We haven't touched it. It's a big, complicated thing. I'm looking forward to Renderman's presentation later today. There's also no flight inside of Cyber City. Cyber City's funding came from the United States Air Force, and as you can imagine, they're constantly asking us for actual flight. The problem is, 100 millisecond delay in a room that is 10 feet by 12 feet means you're smashing against the walls. So we're looking at tethered flight. Tethered flight. We think we can do that. And you say, but quadricopters! But 100 milliseconds is my response to quadricopters. But they can be made super stable, and you can implement software controls to make sure they won't fly. Software controls, yeah. I think tethered flight is our way to go. Tethered flight, yes. The gentleman's question, anything with ADS-B? No. GPS, we don't have GPS transmitters inside Cyber City. However, we do have a location protocol that we ourselves created within the city. And so things do have geo-coordinates, and they can move. There's an API that you can call if you write missions inside of Cyber City, an API you can call to figure out where something is. We also have an API that you can call that will tell you the weather. It will tell you the time of day. It will tell you the air traffic. We do have that airport in Cyber City. It'll tell you how the air traffic is. Nothing actually flies, but we do have planes that take off and land, and you can see that kind of stuff. So pardon me? What do we use for a time source? Just NTP. That's all we're using is NTP. And somebody could attack NTP or spoof NTP, which is part of the actual mission. So we've got a custom geo-coordination protocol right now. Yep. GPS spoofing and such gets to be an issue. There's also just, frankly, an issue of wireless. I mean, do you want to have government cyber warriors getting wireless access to your office space? I don't know about you, but I'm not crazy about that. So what we're doing is actually the wireless infrastructure inside of Cyber City is wireless frames, think layer 2, transmitted over wires, think layer 1. Because you're just sitting there and you put your interface into what you think is monitor mode. Let's say it's Wi-Fi. You think it's in monitor mode because you said to go into monitor mode. It says, I'm in monitor mode. And then you start pulling packets. And wireless frames come out of this thing. They're wireless frames, but they're not actually being sent via radio frequency. So that's how we got around that kind of issue. We experimented. Josh Wright was experimenting with tiny Faraday cages. He was experimenting with the paint. The paint that you can do to implement a Faraday cage sucks, really. I mean, he tried code after code. And this is in a building this big, and we couldn't get it to do enough attenuation. So instead, we had this idea of, let's just send wireless over wires. It's non-trivial from a driver perspective, but still doable. Anything else? I don't want to stand between you guys and lunch. We'll take one more question, then we'll call it a day. Yeah. So intrusion detection, intrusion prevention systems. Some of our missions do require that you be stealthy. So we're actually trying to catch them. What they have to do is to make sure that they don't utilize a lot of bandwidth. They have to make sure that they're not going to do anything that triggers one of our IDS or IPS signatures. Maybe making sure that all their web app manipulation is happening over HTTPS. Intuiting that perhaps we don't have a private key included in our IDS or IPS to be able to decrypt that traffic. So the cyber warrior has to come up with strategies to not trigger our own IDS or IPS. If they do trigger it, we dock them points. All right. Well, thank you, guys. I appreciate your time and attention. Great talking with you.